Okay, now we're going to use the properties of logarithms we just discussed, and we're going to expand logarithmic expressions. And here's an example. I'm going to do several examples, so hopefully it will make sense. So we have the log to the base b of x cubed, and this is actually times, you don't see it, but it's multiplication by juxtaposition, so times y squared. So we can apply our property number 1. The log of a product is the sum of the logs, so that's the first thing we'll do. Log to the base b of x to the third, and plus log to the base b of y squared. So we've applied the first property. The log of a product is the sum of the logs. But now we've got exponents. We can apply the third property, and we can put that exponent in front. So that's just going to equal 3 times log to the base b of x plus 2 times log to the base b of y. So put that 2 in front. And that's all you have to do. So we basically have log of something in some configuration. So that's how we expand. Let's try another example. Example 2. Log to the base 5 of the square root of x over 25. Now the first thing you want to realize or you want to do when you have these expansions is we really don't have a rule for roots, we have a rule for exponents, power. So the first thing we'll do is we'll change this to a power. That's going to be the same thing as the log to the base 5 of x, and the square root of x is the same thing as x to the 1/2. So now we have a power situation all over 25. Okay. And now we can apply the second property. The log of a quotient is the difference of the logs, so we'll do that first. We usually do the exponents last when we're expanding. Minus the log to the base 5 of 25. So the log of the quotient is the difference of the logs. So the log of the top minus the log of the bottom. Now what can I do with this? I can put this exponent in front. So I can say that's 1/2 times log to the base 5 of x. So now I've got that simplified to just the log to the base 5 of something. And minus this. Now you could actually further simplify this if you realize this, because this is an exponent that when I raise 5 to it I get 25. So 5 raised to what power is 25? 2. So I could actually simplify that a little bit more. Call that 1/2 log to the base 5 of x minus 2. And there you go. All right, we can try another one. Log to the base b of x cubed times y all over z squared. So we're going to work our way inside out, and the first thing I'm going to see is I've got the log of a difference here, the top over the bottom, so I'm going to write that. And then sometimes actually you can see that times becomes a plus, and this quotient here becomes a minus, the logs. So the log of a quotient is the difference of the logs. I can write this as the log to the base b of x cubed times y minus the log to the base b of z squared. So the log of a quotient is the difference of the logs. All right. And we can break this up because this is a product now. So I'll write this over here. It's going to get a little bit longer. There's a product. So the log of a product is the sum of the logs. So the log to the base b of x cubed plus, so that becomes plus log to the base b of y. We still have our minus over here. Now what can I do with this exponent? I can put this exponent in front using the power rule. So it's going to be 2 times log to the base b of z. So that's in pretty good shape. And one last thing I can do is I can put this exponent in front. So this is going to equal 3 times log to the base b of x. And then this is already simplified, plus log to the base b of y minus 2 log to the base b of z. And there you go. So that's all simplified out. Okay. So we expand these out, so we just have the log to the base of something, just one thing, and then everything else is moved out. So we've expanded it out quite a bit. Hope that makes sense.